The toluene chart from NeoP1 and NeoPX, those are the same data points on the chart. And you show in the white paper that you inject 750 parts per billion into the sealed 35-liter chamber. And then it looks like one of the charts, the Y values kind of max out at 110, if I remember correctly. And the other one maxes out at like 800. And it's the same dot plot, like it's the same observation data. So the question is, what is the real chart and what was the actual accurate Y values?
Patrick, the new CEO, is going to give a 2-minute intro answer. So I'm going to fast forward to the interesting parts, but I'll link the full video down in the description for full transparency.
The difference between the two graphs that you're talking about is it okay if I'm a bit more technical?
Yes, please.
So the charts are done using a mass spectrometry device. So it's one of those analytical chemistry devices that gives you readings. And at first, what we communicated on, and that was a thought on our own that we corrected afterwards, actually on the second iteration of the NeoP1 white paper, before we launched NeoPX, is the Y column was not normalized to the number of carbon atoms that were in toluene. Toluene has 7 carbon atoms, and the data that showed from the machine gave us the raw data. We forgot simply to divide by 7 the results that we had. So we counted the amount of carbon that were absorbed, not the amount of toluene, of molecule that was absorbed. Does it make sense?
Yeah, it makes sense. You're using the HC51M, right?
Yeah.
Yeah, so I noticed that device measures in ppm and its granularity goes down to the 100th of a ppm. So if I'm understanding, and it also only measures total hydrocarbons. So you're saying essentially you read that ppm value from the HC51M in ppm and then you translated it back to toluene. Is that right?
No, actually what it gives you is not really ppm values. The techniques gives you, it gives you the number of readings. And so the number of readings can be either particles, parts, so toluene, or carbons. Depends on how you set up the machines. And the machine was set up of number of carbon atoms and not number of molecules. So it's basically a normalization problem that we had.
Right, but the NeoP1 data is a different plant than the marble pothos of the NeoPX. And the observation data, whether you scale it for carbon atoms or not, is the same observation data. I overlaid the charts and it's exactly the same.
Yeah, we didn't run this another experiment, just to be clear. It's the same experiment that we've run. But so the difference between NeoP1 and NeoPX is the plant itself that's genetically engineered or not.
Right.
So what we communicated on was the non-genetically engineered plants with the microbiome. And that was the only data that we showed when you could talk about the toluene graph. And so it's the same data set that we used for NeoP1 and NeoPX. The fact that we changed the abscess, it's simply just an error on our part that we corrected later on. But it's the same data sets.
Okay, this part is really important, but was kind of confusing to me. What he said is that they did in fact reuse the graph and data from the P1 study, but that was only about the powerdrops, not about the GMO plant P1 itself. But it's important to note that this graph first came out in the white paper where they said the P1 was the GMO plant plus the powerdrops. Again, you can watch the full interview down below where I grill them a bit more and there's some more back and forth. Now, Patrick's going to show us the test chamber.
I don't know if you can see it right there.
Yeah, I can see it.
Yeah, so this is a 30, ours is 30, the one that we published, I think it's 35-liter chamber with the pothos inside. So you can see that there's a plant.
Right.
And then I'm suspecting, I'm not sure today what we're running, but I'm suspecting there's some microbiome in there that we're testing.
Right.
We have pollution generated here. We have input valve that is here. The pollution goes through the jar and then through the output valve here and connected to various sensors here. Yeah, here I think it's formaldehyde that we're testing in real time. That gives you the value ppm. So these are the types of experiment that we run.
And why are you using 750 parts per billion?
So it depends what you want to test for.
So
I don't know.
So the average indoor air pollution of toluene in like the average Northern California office building is between like 5 and 10 parts per billion. And obviously if you are near a bunch of cars driving on the outside, you might get a spike to 20 or 50. Why wouldn't you be testing at a standardized level that the average household might be seeing?
Yeah, so it's extremely difficult to test in these conditions because the machines that we were talking about only has detection level up to a certain level. It's not that we wanted to put more pollutants. It's that we're at the stage where if you go under it, the machine is not extremely good at detecting it.
Now I'm going to dig in a little bit more about the marketing communications of the product.
If I'm understanding correctly, the main thing that's changing and that you are selling to the consumer isn't the shell. It's not the marble queen pothos. The main thing that's changing the toluene levels in the air is the power drops in the microbiome of the plant. So it would be very clear to simply say, here's plant with the power drops. Here's the same store-bought normalized for biomass plant without the power drops. And then you can see the levels different. And then the consumer can understand truly just what the effect is of what the plant is doing. Because as the data is laid out, even the CADR values, as you guys scale them, it looks like a 10x change, and that's how you guys sell it, as a 10x difference when it's calculated by CADR.
Definitely, that's something that I think we should do because we want to be as transparent as we can on what we test. So this is very good feedback. So we'll do that and be much more clear about what it is exactly you said. And it's right, the power drop, right? Drive the performance. Let me just add one thing and then I'll let you continue, Leo. On the thing that you talked about, what if I just buy the power drops and put it on my plant because I already have plants, etc. Again, we're trying to be data first and as transparent as we can. We don't want to encourage that for people because first we need to test if it works on all the plants because it takes some time to test this. So once we put power drops on the plant, you need to be sure that it stays active for at least a month and then that it drives the right performance because it will interact with the root system, with the soil of the plant, and you have this interaction. That's what makes it last for a month, this interaction between the plant and microbiome. So we're running tests right now because a lot of people, since we launched the product, are asking this exact question. Can I just add power drops on my already existing plants? So now we're running tests with 10 different ornamental plants to just be sure that it actually works on other plants. So that we can communicate it works in this condition, this much, and that condition, that much with these types of plants. And yeah, to answer the question about is there a machine that does that? Yes, there's one machine in the world that goes to this amount of precision. It's called a PTRMS. This is where we're now testing the plants. These are chambers, 16 square meter chambers,
right?
Where we put the plants and we have the detector linked to that. We have 2 of these rooms that we've created. And so this is to run the tests on proper indoor environment, not just this level of pollution, but also all the dynamics that happens in the room. So yeah, I'm very happy to answer any rapid fire question you have.
Yeah, that by the way, that room is really cool. It's great to see you test it in like a room size space instead of just a small chamber. So
and that's what a huge milestone for us as a company because nobody has ever done that.
That's huge.
Any air purifier doesn't do that because it took us like a year and a half to build these chambers and to have the level of precision we want to show later on. So, thanks.
Patrick, can you just talk a little bit about why Leo decided to step down and how you're now the new CEO? Congratulations, by the way.
Yeah, thanks. We communicated, I think, on LinkedIn.
Yeah.
So we created this company 5.5 years ago with Leo, and it took a very, very long time and a team of around 20 people in R&D to create this product. And it was, I think, extremely taxing on him. He's a very intense and very committed person. We've put everything we had in this company. And at some point, it became a bit too heavy. It was taking a toll on his personal life and on his health, psychological, like mental health. And yeah, I think it was the natural thing and the best thing for him, and therefore the best thing for the company to step down of the role of CEO, still be involved, president until the end of the year, and then be involved at the board, But I think the job of CEO and founder for a deep tech startup is difficult. It takes a toll after a while.
And do you think it's fair to say, like, it cleans the air 30 times better when you're just using the toluene number, where clean air comes from PM 2.5, PM 10, BTX, all the different VOX, a bunch of humidity, temperature, all these different things. Do you think it's fair to just say it cleans 30x better?
I don't think it's complete to say 30x better. I would love people to read the white paper, and thank you for reading it, and we're going to do the changes that we need to do. I would like people to learn more exactly about what it is, which VOCs, what are the most harmful ones, why benzene, toluene, xylene, formaldehyde, and then what are results on each of those. Difficult to put that on a tagline. So we want it to still show, like, okay, what is our claim? What's the one thing that we are like, okay, this is something that we can say. 30 times better works, but we try to be as precise as we can where we can. So every time that we have the space we say it's only against VOCs, and specifically benzene, toluene, xylene, more specifically. Is it fair? I would say it's the best we can do if you're going to have a small punchline. Yeah. But what I think is much more important is if people want to dig, they can dig deeper and deeper and go into the raw data and the white paper and ask the questions that you are asking, because they're very relevant questions that we really welcome. And we just want to be clearer, better at communication. So
I think that would be a huge just to do for the company, is to be very clear with the communication and know that a lot of us are going to dig into the white paper. And hopefully, Patrick, you and I can continue this conversation, maybe follow up email. But I'll let you head to the next meeting.